right, hi Algebra 1. This is lesson 7.1, solving linear systems by graphing. So what a linear system is basically it's two or more equations that make straight lines. And the solution of that system is when the two straight lines touch, they intersect at one point. So the purpose of the entire chapter 7 is to figure out where those two lines meet on a graph, and this point right here is our solution, and it will be in a coordinate point. So you will have an x point and a y point. So you can solve linear systems by either graphing, by substitution, or by elimination. Today's lesson 7.1 is all about graphing. Later on in the chapter, we'll learn substitution and elimination method. So steps to solving linear systems by graphing. The very first step is to graph all equations on the same coordinate plane. Now, this step right here is difficult for me to explain in just one way because as we've learned in chapters 5 and 6, there are many different ways to graph lines. So the first way that I'm going to show you is using an XY table. If we look at example 1, it says solve the linear system by graphing. So here are my two equations of lines. I'm going to make an XY table for each of those equations, okay? So actually I'm going to call this first equation the blue equation. And I'm going to write that down here. We have 3x plus y equals 9. Oftentimes we say that it's easier to solve for y to find the xy table. So let's go ahead and do that. If we wanted to solve for y, we needed to get rid of 3x. So I'm going to minus 3x from both sides of the equation. Now I have y equals negative 3x plus 9. Okay, now I can go ahead and make my xy table. It's always easiest to start with numbers that are very small. So like if we plug in 0 for x, so I'm plugging 0 right in there. We have negative 3 times 0 is 0, plus 9 is 9. What if we plug in the number 1? Negative 3 times 1 is negative 3, plus 9 is 6. If I try one more, let's plug in like 2. Negative 3 times 2 is negative 6, plus 9 is the number 3. So now we have a few points. We can go ahead and graph this line. The coordinate point 0, 9, if I go 0 in the left and right direction, and 9 up, noticing that it's going by 2's, that's that point right there. 1, 6 would be here, and 2, 3. All right, so here's my line for this blue line, 3x plus y equals 9. I'm going to switch colors. I'll do this one in red. So now we have x minus y equals negative 1. Again, solving for y, we can minus x on both sides. Now we have negative y equals negative x minus 1. And there's a hidden number right here. This is negative 1y. So if I wanted to get rid of that negative 1, I would divide everything by negative 1. That leaves me with y equals, let's see, here we have another hidden negative 1. So negative 1 divided by negative 1 is just 1. So 1x, and then again negative 1 divided by negative 1 is 1. Making an xy table for this equation, plugging in 0, 0 in here for x, 0 plus 1 is 1. Plugging in the number 1, 1 plus 1 is 2. And let's try plugging in the number 2. 2 plus 1 is 3. So I'm going to go ahead and graph these lines now. We have 0, 1, 1, 2, and 2, 3. Noticing that this 2, 3 point right here looks like that is our solution to the system. So both the blue line and the red line intersected at the point 2, 3. So that is my answer. That coordinate point 2, 3. Okay, I would like to show you another way to solve these, just in case you prefer using slope-intercept form. So if you remember from before, slope-intercept form is y equals mx plus b. Okay, so if we were to solve both of these equations for y, then we can use slope-intercept form. All right, so I'm going to color code this first one again with blue. All right, in solving for y, I would minus 4x on both sides. Now we have 2y equals negative 4x plus 12. And I could divide 2. I could divide everything by 2. So now we have y is equal to negative 2x plus 6. Just a reminder here that this plus 6, that is my b value, and this negative 2, that's my m. Okay, so a b value of 6, that is where it intersects on the y-axis. Here's 6, and negative 2, a slope of negative 2 means I go down 2, 1, 2, and over 1. Since I am trying to find like where the two lines intersect, that point right there on this graph, I'm going to go ahead and I'm going to do the slope and plot a few more points kind of all up and down this. So because I was going down 2 over 1, now I can go up 2 over 1, up 2 over 1. And connect all of these points to make a line. All right, I'm going to do the exact same thing with this next one. We have 2x minus y equals negative 10. So minus 2x on both sides. We have negative y equals negative 2x minus 10. And we can divide by negative 1, just like we did in that last problem. So we'll get y equals 2x plus 10. All right, our b value, our y-intercept is the 10. That's this point on our y-axis. And our 2 is the m, which stands for slope. So that means I would go up 2 over 1 to the right. Now if I went up 2 and over 1, notice that that's off the graph. So that's the same thing as going down 2 and over to the left 1, which I can already see right there what my point of intersection is. It is this point right here, which is the coordinate point negative 1, 8. So that is my solution to this problem. Notice that the coordinate point, that is actually the solution to the problem. Not necessarily any of this other work that I wrote down below. The solution is this point here. All right, we do have a few more examples. Example 3. I will show you one other way. This one could be using our x and y intercepts to solve this problem. So if I have 4x plus 2y equals 6, 4x plus 2y equals 6, making an xy table for that. Let's say I plug in 0 for x. Okay, so that means I have 4 times 0, which is 0, plus 2y equals 6. All right, I could divide by 2 on both sides, so y will be equal to 3. All right, I could also plug in a number for y. So I could plug in 0 in here for y. Then we have 2 times 0, which is 0, and then we just have 4x equals 6, which we are going to get a fraction there. If I were to divide by 4 on both sides, x will be equal to 3 over 2. 3 over 2. That's 6 divided by 4, and then simplified. If I were to divide both of those two numbers by 2, that gives me 3 over 2. Okay, so I can go ahead and graph this line now. We've got 0, 3. And 3 over 2, you kind of have to guess where that is. That's right about here. Okay, this is kind of where you can see sometimes graphing isn't always like the easiest way, because when you are dealing with fractions, you kind of have to guess where that is on the graph. So I'm going to notice that this is going down 1, 2, 3, and over 1.5. So if I wanted to follow that through, I would go down 1, 2, 3, and over 1.5. That would put me about right here. Okay. Now I'm going to do the other equation in blue. We have 3x minus 3y equals 9, making an xy table. Plugging in 0 for x, so then we would have negative 3y equals 9. Dividing both sides by negative 3, y would be negative 3. Plugging in 0 for y, negative 3 times 0 is 0, so we would have 3x equals 9. Again, dividing both sides by 3, so x would be 3. Plugging those, or putting a coordinate point on those, we have 0, negative 3, and 3, 0. Okay, so here if I'm looking at these 2 points, it looks like I'm going up 1, 2, 3, and over 1, 2, 3. That also tells me that I have, if I'm going up 3 and over 3, that means I have a slope of 1. Going up 1 and over 1, up 1 and over 1. So that kind of helped me figure out that my coordinate point is this point right here, which is the coordinate point 2, negative 1. That is actually my solution. That's my answer to this one. So this method, it works okay, except for the fact that like right here on the first equation, we ended up with a fraction, which made it a little bit not as easy to work with. Okay, I'm going to go and do another method like example number 2, which is using the the slope-intercept form. Okay, here's my blue equation. So we have 2y equals 6x plus 8. And I'm going to solve for y, so I need to divide by 2. Then we get y is equal to 3x plus 4. All right, keeping in mind that this is my b value, my y-intercept, which is right here on the graph, and my slope of 3, which means I go up 3, 1, 2, 3, and over 1. That's also the same thing as if I go down 3, 1, 2, 3, and over 1. We can do that one more time. Down 3 and over 1. All right, here's my new graph. Okay, now we have 4x plus y equals negative 3. Again, solving for y, I would minus 4x on both sides. So we get y is equal to negative 4x minus 3. My b value here is negative 3. That's where it is on the y-axis. And my slope is negative 4. That means I go down 4 over to the right 1, or the opposite I could go up 4, 1, 2, 3, 4, and over to the left 1, which right there I see is my point of intersection. That means that's the solution to this system of equations. So this point right here, which is the point negative 1, 1. That is my answer to that problem. Okay, we have one more example left. I will go ahead and use the XY table method again since I haven't done that one for a while. All right, so my blue equation, we have y equals 4x plus 4. If I am doing an xy table for that, again, I can plug in anything for x. Let's do 0 and let's do -2. If I plug in 0, 4 times 0 is 0, plus 4 is 4. Plugging in -2 right in here for x, 4 times -2 is a -8. -8 plus 4 is -4. I'm going to go ahead and graph those 2 points, 0, 4, and -2, -4. Okay, that is my line. Okay, here's the last one. We have 2y equals -3x minus 14. I want to solve for y. I want to get y by itself. So this is 2 times y. How do you undo times? You divide by 2. So we have y equals -3 over 2x. I can't simplify that anymore. And then -14 divided by 2 is a -7. Making an xy table again, I'm going to choose also the numbers 0 and -2. See what happens. 0, plugging in for x. So we have -3 over 2 times 0, which is just 0, and then -7. If I plug in -2, I chose that number because then we have this. We have -3 over 2 times -2. Those 2's cancel, so it makes it easier. So then I just have -3 minus -3 minus 7. Oh, excuse me. This is a negative times a negative, so that makes a positive. So it's like saying 3 minus 7, which is -4. Okay, plotting these points, we have 0, -7, and -2, -4, which I can see is right there. So that is my point of intersection. That means that's my solution to this problem right here, is the point -2, -4. That's my answer. So just to be clear, the main purpose of this lesson was to say, where is that point of intersection of our lines? That is called the solution of a system of linear equations. It is this point on a graph where two lines intersect, where they touch. And you will find that with a coordinate point, an x value and a y value. All right, I hope you enjoyed our first lesson in Chapter 7. Thank you for watching.